All right, it's 3 minutes past the hour. A warm welcome to the PHEMS meetup for April. My name is Pekka Kahri. I'm working at the Helsinki University Hospital and I've been coordinating the PHEMS project. Today's topic is around getting your hospital ready to join PHEMS or ready to join the pediatric health data space. We have a series of meetups this spring consisting of 3 topics. Today we will have Mikko Juvonen from Helsinki University Hospital talking about what is required from individual hospitals to be able to participate in data sharing activities that we are designing in PHEMS project. Then in May 20th, we will have Dr. Martin Knossen from Erasmus Medical Center talking about one of our clinical use cases, improving treatment for pediatric patients with hemophilia. And then in June 17th, we will have our business partner, Genesis Biomed, talking about the opportunities of using the pediatric health data space to support clinical trials, patients with unmet needs. So this is our spring series, 3 sessions, always at this hour on the 3rd Tuesday of the month. Just reminding why we are doing the project called PHEMS, which is pediatric hospitals enabling data sharing, because in pediatrics there is an urgent need for safe data sharing cross borders. The patients that the pediatric hospitals are treating are small in numbers, and there are lots of rare diseases. So there are limited abilities to conduct research, develop new therapies, and improve patient outcomes. If only tapping into a single.
Are you seeing the slides? I think the slides went away.
Okay, I will share it again. Thanks, Jennifer, for.
Sorry about that. I'm not sure.
How about now? Yep.
Yep, looks good now.
Brilliant. So there is a need for to increase or have any statistical power for research. We need to be able to somehow share data cross-border. When there are new expensive targeted therapies that are brought to the market, data is needed to do reliable health technology assessments. If we want to develop new algorithms or develop AI, we need a lot of data and a way to engage with innovative algorithm developers. We need some sort of data collaboration mechanism cross-border. And then if we want to do benchmarking and improve the clinical activities through comparison and mutual learning between hospitals, so we need to have a way to do it cross-border. And that's why we have put up together PHEMS, a project funded by the Horizon Europe program and the UK Research and Innovation. And the partners are leading pediatric hospitals or departments of pediatrics in general hospitals in Europe, coordinated by Helsinki University Hospital, GOSH, Great Ormond Street Hospital from London, Erasmus Sophia Children's Hospital in Rotterdam, Sant Joan de Déu Barcelona Children's Hospital, Riga Children's University Hospital Latvia, and Mayors Children's Hospital in Florence, Italy are the clinical partners. And then there are technical and business partners also supporting this work and participating in the project. We're totally 14 partners and have received 7 million euro funding from Horizon Europe and UK Research and Innovation Agency, and we're exactly halfway in our project, so a 3-year project which will be ending in September 2026. The goal of our project is to create something sustainable, a way to collaborate on data also after the project has ended, and this collaboration structure or what we want to build, we call it the pediatric health data space, meaning that it consists of both technical and then legal and administrative structures to work continuously with collaborating data. And we are covering in these meetup sessions from several perspectives how the pediatric health data space works And if you want to visit any of the previous meetup presentations, so feel free to go to the YouTube channel of our project and check the preceding presentations from there. But today's presenter is Mikko Juvonen, a dear colleague of ours from Helsinki University Hospital, who is acting as the technical coordinator of our project. He's been working with data lake technologies and artificial intelligence for several years, has a strong background in technology management, and is a key character in our PHEMS project on its path towards a sustained and value-creating pediatric health data space. With this, I will give the floor now to Mikko. Mikko, the floor is yours.
Thank you, Pekka. Also, on my behalf, I thank you for joining. It's nice to have a couple of people here. My presentation today about how to prepare yourself for the PHDS. Just a second. Right, so how to prepare yourself for the PHDS. My presentation today will be in 4 parts. I will first discuss a bit about the PHDS network structure. What do we mean by it? What do we mean by PHDS, and how the network is built? Then I will talk about data harmonization. That is the key for any kind of networked activities. The third part will be about the technical readiness. So what kind of technical capabilities are needed for different partners to be able to join the network. And then in the end, I will also say a few words about current status of the network implementation. So where we are with the implementation in the PHEMS project. So first, the network structure. We have in the network, we have different roles. The organization or the parties who will be joining the network, they will all have their own roles. The different roles, of course, have different kind of requirements put onto them, and the plan now is to build standard contracts for different kind of roles, so that it is clear what is expected from each and everyone joining the network. We will also create supporting documentation. It's not just the legal contracts, but we will also provide operative rule book and governance rules documentation to support the activities within the network. How does it look like then, the network? This is a simplified picture about the network. On the right hand side, we have the data controllers. Those are the organizations that hold the actual data, electronic health data records, and it is their job to make harmonized data available so that it can be used within this network. In the middle, we have centralized services. That is the coordinating entity which will handle the coordination and the life cycle of each and every individual project which will be run within the network. Then towards left, we have the workspace. In this picture, we only have one workspace, but what we actually plan is then, and what the technical architecture does not really limit us to one workspace. So we could actually have many different kind of workspaces depending on the type of use for the workspace. So we would have workspace providers. Those are the organizations that provide services for the data users and the projects, so that the projects will be able to make use of the whole network. And on the left we have the data users, where we have the actual users making use of the data. I mentioned the contracts and the supporting documentation. The plan is also to create implementation guides for the different types of use cases in the network. We see that we have these different type of use cases, starting with the feasibility and the availability studies, which can be run using the network. That is something which currently, thinking about the network studies, it is not easy to get information where data would be available for a specific type of study, for example. Using this network for feasibility and availability study would be much easier, so that we can get an easier way of finding out the data availability from the whole network instead of just one data controller. Then another type of use would be benchmarking. We could talk about operational benchmarking between the hospitals, and we could make these benchmarking activities automated. Currently, typically when these type of activities are done, it is mostly manual work, and with using this infrastructure we are building, that would be automated. Then we have the normal network studies, research projects, where we can make use of the network. The fourth point of the decentralized machine learning is also something which is planned, so we could actually use the infrastructure for distributed machine learning, so we can create models and we can learn models without having to centralize the data in one place. Then moving on to the data harmonization. This is maybe the most important point in this presentation. I cannot stress enough the importance of the data harmonization. Without it, we cannot really work in the network way, and it is also important to understand that we have to have a standardized model so that the data can be used within the network. Within PHEMS and the PHDS, we have chosen the OMOP common data model as the model for harmonization, and this is becoming a de facto standard within this field in medicine, and it offers a lot of resources, tools, guides, and those can be accessed through the Odyssey community. If you are not familiar with this, I urge you to go into the OSDSI and and investigate what you can find there. In practice, the mapping of the data, of course, the data in the hospitals is within the electronic health record systems, and it is not an easy or small job to do the mapping towards this common data model. It requires significant resources, and of course it's not a one-time effort. Integrations need to be built and pipelines for the mapping need to be created. One thing to note is that this is not purely an IT challenge. Of course, a lot of clinical expertise is also needed in this activity. So to prepare, this is probably the most resource demanding task. Then the technical readiness. What kind of capabilities do we need on the data controller side to be able to be part of this network? This is a high-level picture of the network from another aspect, which shows how the network works. On the right-hand side, we have the data controller, and the data controllers will host a so-called federated node within their IT infrastructure. This federated node will have access to the OMOP harmonized database, and this is, of course, it could be several different databases depending on how the infrastructure is built. We could have one OMOP database, or we could have project-specific databases. Then starting from the left, we have the workspace where the researchers, the data users can work with their analysis code. What they will do, they will push the developed code to the centralized services, where the code can be inspected, reviewed by the data controllers experts before allowing it to be run. So from the centralized services, the approved code will be drawn into the federated node. The federated node will execute the analysis towards the data, and then it will return the results to the centralized services. There, again, the data controllers experts can review the results so that the information security is kept. When the results are approved, then they can be returned to the workspace where the researchers and the data users then have them available. In a bit more detail, so within the data controllers infrastructure, what we need the OMOP harmonized data. We need to make that accessible for the federated nodes. The federated node will run on top of a Kubernetes cluster. The way that is implemented is there are a number of different ways to do that. The Kubernetes cluster can be a hosted service in the cloud, for example, like AKS, Azure Kubernetes service, or it can be run in a smaller on-premise setup. We could have a Linux virtual machine running the Kubernetes, for example. The implementation choice there is depending on what the hospital wants and what kind of infrastructure they have. Then for managing the Kubernetes installation, we have selected a tool called Argo CD. That is the tool which is used to control and manage the configuration, the installations within the Kubernetes cluster. We also use the Argo CD for this code transfer and the result transfer, the container synchronization. The code and the results will be moved within containers. The centralized services, that is built on top of a GitHub Enterprise service. It is not like a common GitHub, it is GitHub Enterprise, just to be sure to make the difference there. It is not an open source project. We have strict access control. It provides us with a lot of different functionalities on the shelf. Version control, audit logging, audit trail. We can track changes. We can see who has provided what code and who has approved. That is very important when handling the hospital data. It also provides us with the CI/CD pipeline, which is used for the packaging of the code, and the result delivery also happens through GitHub. Then to the current status of our development work, the highlights. As Pekka said, we are now halfway in the project, and what we have achieved so far, we have the GitHub Enterprise established for PHDS. That is, of course, not ready in all detail, but it is. We have done it. We have the federated nodes installed in our partner hospitals. We have run the first analysis codes through GitHub, and we have seen that the automatic execution of the analysis code works, and we have also been able to return the results through GitHub already. The conclusion. So, first of all, I hope that you now have at least a high-level understanding about what we mean by PHDS, what is the network structure. The most important thing for preparing or for preparations is the data harmonization. If you have not started activities on this front, it is a high time to start. Then the technical capabilities. It is not many things which you need to take care of, but this handling of the Kubernetes installation and understanding the process flow is important. And then my last point is that we can do it. We have already done it. It is not just PowerPoint anymore. We have done the first implementations, and they are running. This is the end of my presentations. Thank you.